Welcome to the Green Chemistry class. Let us continue the 12 principles of green chemistry part 2. I hope you are all familiar with the first 6 principles of green chemistry. Shall we recall them? Yes, you are correct only if they are prevention, atom economy, less toxic products, designing safer chemicals, safer solvents and auxiliaries, and minimum energy requirement. Let us see the remaining principle in this video. Seventh one is use of renewable raw materials. A raw material should be renewable rather than depleting whenever technically and economically practicable. Example, polylactic acid is the polymer of lactic acid. This is green synthesized from renewable raw material corn. This polylactic acid polymer replaces the polythene. Therefore, it is known as bioplastic. Bioplastic is a boon for environmental protection. Next one is reduce derivatives. Unnecessary derivatization should be minimized or avoided if possible by using blocking groups, production or deproduction process, etc. Here, the conversion of penicillin G into 6-amino-penicillic acid is given. It is done by the suitable immobilized enzyme. It is a single-step synthesis and also considered as green synthesis. It improves the yield, minimizes the hazardous reagents and solvent usage, and finally decrease the waste production. Next, catalysis. The use of biodegradable catalysts like enzyme protect the environment through minimization of energy, avoid use of organochlorocompounds, and reduce the use of water. Like other catalysts, enzymes lower the energy of activation of reactants and thereby promote the rate of reaction several million times. The biocatalysts remain assets without any change till the end of the reaction. For example, the conventional synthesis of catechol from benzene involves 3 stoichiometric reagents with 3 steps and many byproducts also formed. But the green synthesis of catechol from glucose using genetically modified E. coli involves no byproduct formation. Next, design for degradation. The products that are synthesized should be biodegradable, non-hazardous to human health or environment, and easily discarded. Pesticides and plastics are non-biodegradable. These pesticides tend to bioaccumulate in plants and animals. By green synthesis, it is possible to make biodegradable polymers and biopesticides. Example, polypropylene carbonate, which is biodegradable polymer, can be synthesized as shown here. That is, carbon dioxide reacts with epoxide along with catalyst to form polypropylene carbonate. The next one is real-time analysis for pollution prevention. Alternative methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. For example, in the traditional method of blood analysis, 5 ml of blood sample is required for blood sugar estimation. Time consumption is also very large, but with the advanced glucometer or paper strip method, only 0.1 ml of blood sample is sufficient to carry out the test within few minutes time. Okay. The 12th principle is avoid chemical accidents. Substances and the form of a substance used in the chemical process should be chosen to minimize the potential for chemical accidents like explosions, fires, harmful vapors. There are some principles has to be adopted for the industrial safety. They are minimal use of personal protective equipment, implementation of administrative and work practice control, adopting engineering control, and employing substitution procedure. Now we are going to list out the principles what we have seen so far. Use of renewable raw materials, reduce derivatives, catalysis, design for degradation, real-time analysis for pollution prevention, and avoid chemical accidents. We will see in the next video with different topic. Thank you.